Sweet. Hello, everyone. Thank you for joining me in the freezing cold. I'm excited to be here. I think I missed some of the talks yesterday, but I thought about what I could talk about from a Polygon's perspective. I got asked to see what Polygon's direction of AI was, and I thought to myself, well, how about I take the contrarian approach and see how Polygon is trying to kind of combat the AI and the bots that we see in Web3 and crypto today. So today I'm going to be introducing, I feel kind of weird standing in the middle of my slides here, but I'm going to be introducing Polygon ID. And Polygon ID, for those of you who don't know, is our decentralized identity platform that is actually kind of spun out into its own company as of a couple of weeks ago. So first, I'll introduce myself. So I'm a developer relations engineer at Polygon Labs. I've been here for about 9 months. And basically my job is to help people build on Polygon and understand the tools and products that Polygon is building. You can follow me or find me on Twitter, YouTube, whatever you want. I'm on pretty much everything. You can just search for my name. All right, so I'm not going to waste any time. I wanted to introduce what Polygon ID actually is. So I'm just going to use my voice because I want to read the slides. Polygon ID is essentially an open source system that allows users using zero-knowledge proofs to prove some aspects of their identity without revealing that information itself or anything about why that information is true. And the second point here is essentially, it's in a nutshell, in one sentence or 5 words, it's using zero-knowledge proofs to hide PII, which for those of you who have ever worked in data analytics or stalking people on Facebook ads or anything like that, basically means anything that you can associate to an individual. So that could be your full name, your address, your date of birth, your nationality, any aspect of your identity. And often we don't want to give this information away to anyone, really. We don't want to give it away, especially to online. Oh, I'm going to use the mic. Sorry. Oh, that'd be great. Thanks. Thank you, that's better. Thank you, sir. Thank you. Cool, so yeah, in a nutshell, we're basically trying to prove some aspect of our identity to typically applications that want that information, but we don't want to give that information away. All right, so I'm sure if you're in Web3 and especially at ETH Denver, you've probably heard this sentence about 500 times in the past month, but just as a quick recap and to try and solidify what the purpose of zero-knowledge proofs are, I just have like 1 or 2 slides to go through this and put the zero-knowledge proofs in the context of Polygon ID. So the goal of zero-knowledge proofs here is to prove the validity of a statement without revealing that statement itself. So I want to prove to you that my name is Jared. I want to prove to you that I'm from Australia. I'm working at Polygon. But I don't want to tell you any of that information. I just want you to know whether or not that is true or false. And this system, typically, you can kind of simplify it down to 2 parties. The 2 parties are the prover and the verifier. So these names are kind of self-explanatory. The prover is trying to prove something. So for example, if I was trying to tell you that I am in fact named Jared, I am in that situation the prover. And if you're wanting to know my name and you actually want to verify that that is true or false, you in that situation are the verifier. And the thing that gets passed along is often called a witness. The piece of information that you want to provide is often called a witness, and that is kind of abstracted in the form of a zero-knowledge proof. So the prover provides a zero-knowledge proof to the verifier, who then verifies that zero-knowledge proof, and the outcome of that whole system is to basically say, well, yes, I believe what you've said, or no, I don't believe what you've said. So if we kind of put this in the context of SpongeBob here, this is like an imaginary situation where SpongeBob's been pulled over, he's been speeding in whatever his car is, and the policeman or the police fish here is basically going to say, hey, I want to find out some specific piece of information, such as if SpongeBob is actually a qualified driver. He has a valid license, let's say. He just needs that one piece of true or false information. But in the real world situation, you know, when you or I get pulled over by the police, or SpongeBob gets pulled over by the police, he has to hand over a huge amount of information with typically your license, right? You're going to give the license and registration over to whoever is pulling you over. And on my license, I have my exact date of birth, my full name, where I live, my signature, so much information that I don't want to give away, yet I'm kind of forced to actually prove this one tiny true or false piece of information to this policeman here. So what zero-knowledge proofs enable is to actually prove that true or false statement without handing over the information itself. And especially important in this part is I'm actually not only not handing over the information that the person cares about, but I'm also not handing over all of that contextual information that goes kind of alongside that document that the verifier trusts. So zero-knowledge proofs, the TLDR, especially in the context of Polygon ID, is that they enable us to prove things without revealing what that thing is or why or how it's true. And the verifier is still satisfied because the criteria that they're checking is still kind of satisfied because they end up with a true or false statement from this full process. All right, so I'm going to introduce a third party to this prove of verifier system, which is called the issuers. So issuers are the ones that generate these documents called verifiable credentials or VCs. So verifiable credentials, as you can see in this screenshot on the right-hand side here, is an example of what a verifiable credential might look like. So this is a credential that contains my birthday, and then the document type is just something that's specific to Polygon ID right now. This is not my real birthday, it's just a test, so it's just an example of what one might look like. So on the right-hand side, we have a credential that the prover is given by the issuer. So the prover, for example, SpongeBob or myself getting pulled over by the police, would hold this in either their wallet or any of the kind of open source apps built on the Polygon ID protocol. So issuers, and we'll talk about what an issuer is and some examples in the next couple of slides, issuers are the ones generating these VCs and giving them to the provers. So some examples of an issuer might be the government. So the government would give you some credentials to say, hey, you are of a certain nationality. This is your full date of birth. This is your full name, right? Some personal information in the form of a verifiable credential. Another example might be, for example, universities. So universities, the obvious use case here is to say, well, you've actually graduated with this degree, with this GPA or whatever is used in the US here. For me, it's like a grade that you get along with the document that you get for graduating. Another example might be hospitals. Maybe this is actually kind of an interesting one, right? Because you don't want to give away a lot of the sensitive information about your health conditions or some problems that you might have with your health, right? So these verifiable credentials have a lot of power, especially when they're given from entities that a lot of applications are going to trust. And the final example that I put at the bottom here is your backend. So the great thing about the Polygon ID protocol is that anyone can actually build on top of this, right? Anyone can be an issuer. That means you could be running any custom checks and issuing any custom verifiable credentials to any of the users of your application, or in our little analogy here, the provers in this system. So that could mean you could, on your API, let's say, plug into a Web2 API to say, maybe, for example, the Twitter API. You could say, hey, does this person actually own this account? Does this person have a certain number of followers? Or this could also translate to things on chain, such as, does this person hold a certain number of tokens? Does this person hold an NFT? And award a verifiable credential that the user can then use to prove pieces of information without giving that information away. So if you revisit our bikini bottom analogy here, we've added a new player into the mix, into our proof of verifier system, which is Mrs. Puff here, which is the issuer. So the issuer in this situation is kind of, if you've never watched SpongeBob, Mrs. Puff is the lady who runs the driving academy and gives SpongeBob his license. So in our zero knowledge proof world, the issuer would grant the prover a verifiable credential. In this case, let's say it would say, yes, SpongeBob is a qualified driver, or yes, SpongeBob's name is actually SpongeBob, and his license is valid until a certain date, and the rest of the system remains the same. An important thing to note in this slide is there is also a relationship between the issuer and the verifier. So importantly, the verifier can actually list what issuers it wants to trust, okay? Because let's say if I just gave myself a verifiable credential to say, yes, I'm a qualified driver forever, and I can drive high-speed motorcycles and trucks, I could do that to myself if I wanted to. The verifier doesn't want to trust those kind of sketchy or verifiable credentials from any source, right? It wants to say, hey, I only want to trust the United States government as an issuer. I only want to trust these institutions as an issuer. So there is an aspect of trust between the verifier and issuer where it can say, hey, I only want to trust certain sources of verifiable credentials that the prover can provide. So here's like another example, and the reason I made this slide is the credentials, importantly, can be used for any number of applications, right? It's not a one-to-one relationship from credential to application. So I just put like some stupid examples that I came up with of different applications that you might want to provide these zero-knowledge proofs for. So for example, Stake, for those of you who don't know, it's a gambling website. Maybe I don't want people to know I'm gambling, I don't want to give a gambling website away my full identity, that's understandable. You could relate this to some other sketchy websites as well. But you don't want to give your personal information away to these websites, but these websites have a legal requirement to say, is this person over the age of 18, or is this person within certain jurisdictions of the world? And that can be related to things like Coinbase, for example. They only want to serve certain customers who have verified their information. And if you've ever used Coinbase, you have to upload full picture of your license, full picture of your passport, and that's just an uncomfortable situation for users to be in. The same would go for things like games, like League of Legends. In some countries, you have to have a certain age to play these games. You are only allowed to play these games for a certain amount of time per day. And the same goes for any social media app. They all have these legal requirements where you need to prove some aspect of your identity in order to use the platform. But either they just have a checkbox that you say, yep, I'm over the age of 18, and we all know that that is abused by teenagers and has very negative effects, but that is probably a topic for another time. So the point here is the credentials that you receive, let's say I received a credential that I'm 25 years old, I can use that for any number of applications that want to check that information. And this is just another third example. We probably don't need to go too much into detail here, but an example here would be me graduating from Harvard, which I did not do, and I get a verifiable credential, and I can then use that for things like job applications. Right? This is a common example of people faking what degrees they got and what universities they went to. What if we had a system in place where you could actually prove that information to these people searching for it? Okay, so we've talked a lot about Polygon ID, and I obviously know this is an AI presentation, so where is the AI? And I thought, like, how can we actually relate this back to what's happening in the space today and what this has in common with the AI that we're talking about? So I kind of took this approach to say, well, AI can be used for good things in blockchain space. It can also be used for bad things, right? And what we're seeing recently is this kind of airdrop meta where people are creating bots or full-on farming operations to say, I'm going to perform certain actions on chain to try and qualify for this kind of money printing process that is the airdrops from things like Starknet recently or in the Solana ecosystem. Depending on how degenerate you've been, you've qualified for these different airdrops in different ways. But there is, like, from what I've heard, I don't know this for a fact, but there is literally full offices of people running these bot operations to try and qualify for these airdrops that chains are running. And obviously these accounts are not human. And my personal take is like a massive percent of the activity that we see on a number of L2 and Alt L1 chains today is actually just bots kind of trading between each other. So how can we prevent these kind of Sybil attacks that people run using a system such as Polygon ID? And hopefully the answer is kind of an obvious one, is you can provide these verifiable credentials to add a layer of kind of proof of humanity to these processes. So you could prove your users are human based on your own custom criteria to say, I'm going to award a verifiable credential to users who meet any criteria that I want. That could be having a verified Twitter account. It could be being verified on some other platform. It could integrate with other on-chain decentralized identity platforms like Gitcoin Passport. Do they have these credentials available associated to their wallet to prove that they are actually a human and not a script running in an office? You could also do the same thing, like for example, the Starknet airdrop. They didn't want people from the US to claim because I think it's a bit of a legal mess for US people to actually participate in these airdrops. So you could prove your users do not have some attribute, such as require them to have a verifiable credential, that they are from a certain country, right? They have that piece of information associated to them, but that value is not from the US. So you could do this to kind of filter out exactly what criteria you want these humans to actually have, and use that to control what rewards you're giving for your protocol to actually decentralize the governance of that protocol that you're building. Sweet, so I was kind of hoping that I would have my laptop here, but luckily I have screenshots in the deck as well. So depending on how much time we have, I'll just quickly check. We've got, I think we're a little bit over time, but that's okay. So I wanted to show you what this actually looks like in practice, right? So what does this actually look like? This is a two-step process that we can break down. So the first step for provers is to say, well, how do I even get these credentials, right? How do I get one of these credentials and associate it to my identity? And this is what we're gonna go through. So the first, this is, before I go through these screenshots here, Polygon ID does run their own application that is built on top of the protocol called Polygon ID, and it's available on the App Store or on the Android store, whatever you're using. But importantly, this is completely open source, so anyone can build this exact same application and run their own custom implementation of this as well. So this is step number one. The prover wants to get a credential. So the process that they would do is they would visit a website to say, okay, I've proven some aspect of my identity, I'm ready to receive these credentials. They'll scan a QR code, and that leads into step number one here. So sorry, that's not step number one. Step number one's on the other side. So step number one is on the right. I think I messed this up. Step number one is on the right, where you can see it says this organization is ready to give you a credential. And what that's doing is saying, well, you've somehow proven based on your application's backend logic that I'm ready to give you this information that you can hold inside of this open source protocol, but more importantly in this application that you can use through any number of applications to prove aspects of your identity. So the first step is to say, hey, I'm actually going to accept that this application has given me a credential. Once you click that accept button, this is the second screen in the middle. Some reason I did right to left, so that's my fault. But you can see my data. I have two verifiable credentials so far. And if we click into one of these credentials, here's what that actually looks like. So you can see here is my birthday, and here's like when it was awarded, what type of proof it is, and all the technical details of who this was issued by, which is important here. As you can see, maybe you can't see, but down the very bottom you can see that this was issued by a certain issuer that is going to be used by certain applications to say, hey, I only want to trust certain people who gave out these credentials. So, sorry, I did it in reverse for some reason, but that's the first step of the process to receive a verifiable credential as a prover from an issuer. So step number two is now I have these credentials to say, yes, I was born in 1996. I can actually prove that to verifiers. In this case, it's going to be applications that want to prove the users are of a certain age. So hopefully I've done it in the right order this time. There we go. So on the left here, this is the first step of step number two. So the process for the user to prove they are of a certain age, for example, would be, again, they scan a QR code on the website, and this will take them to this stage of the proving process inside of the Polygon ID application. So the first step here, as you can see, this organization requests the following information. And you can see it's asking if my birthday is actually of a certain age. And the format that it does that is your birthday smaller than or greater than a certain date? And you can see I passed that criteria. This information is not presented to the application. Importantly, when I click approve, this middle process occurs. You can see it's saying generating a zero-knowledge proof for the credential you're ready to share. So the application never receives my birthday. It never receives any personal information about me. All it receives is this kind of mathematical representation of that information. And the final step is the proof is generated, and the application will accept that information as it verifies the zero-knowledge proof that it received on its server or its backend. And that's pretty much it. So I have a little bit of time for questions, I think, if you have any. But yeah, thank you very much for coming out in the cold and listening to me talk. Is there any questions, or are we all good? Not airdrop specifically, but we're kind of in the development phase right now where we're working with banks as an example of an institution that is interested in saying, well, here's some pieces of information that we want our users to hold but don't want them to share with other companies. I can probably talk to you more in private on like what specific applications are working with Polygon ID and find out more information on that as well. Yep. Yeah, great question. So there's actually two approaches that you can do. You can do this on-chain. So there are smart contracts on the Polygon chain that allow you to perform this full flow of verification on-chain. But the example that we demoed here today was this is all off-chain. So my phone is just holding verifiable credentials, and the server that I built, I did have a little website demo that maybe I can show if you're interested later, but the server that I built is just a Next.js app. The server says, okay, I'm gonna accept the proof, and then it just runs that verification logic and spits out the outcome of, yes, that verification process was a success or not. So there's kind of two different approaches that you can take, on-chain or off-chain. Yeah. Sweet, thank you.